A flashlight is a portable handheld electric light. Usually, the source of the light is an incandescent light bulb, light-emitting diode. A typical flashlight consists of a light bulb mounted in a reflector, a transparent cover to protect the light source and reflector, a battery, and a switch. These are supported and protected by a case. The invention of the dry cell and miniature incandescent electric light bulbs made the first battery-powered flashlights possible around 1899. Today, flashlights use mostly incandescent lamps or light-emitting diodes and run on disposable or rechargeable batteries. Some are powered by the user turning a crank or shaking the lamp, and some have solar panels to recharge a battery. In addition to the general-purpose handheld flashlight, many forms have been adapted for special uses. Head or helmet-mounted flashlights designed for miners and campers leave the hands free. Some flashlights can be used underwater or in flammable atmospheres. Etymology: early flashlights ran on zinc-carbon batteries, which could not provide a steady electric current and required periodic rest to continue functioning. Because these early flashlights also used energy-inefficient carbon filament bulbs, resting occurred at short intervals. Consequently, they could be used only in brief flashes, hence the common North American name, flashlight. History: in 1887, the first dry-cell battery was invented. Unlike previous batteries, it used a paste electrolyte instead of a liquid. This was the first battery suitable for portable electrical devices, as it did not spill or break easily and worked in any orientation. The first mass-produced dry-cell batteries came in 1896, and the invention of portable electric lights soon followed. Portable handheld electric lights offered advantages in convenience and safety over torches, candles and lanterns. The electric lamp was odorless, smokeless, and emitted less heat than combustion-powered lighting. It could be instantly turned on and off, and avoided fire risk. On January 10, 1899, British inventor David Missel obtained a U.S. patent No. 617,592, assigned to American Electrical Novelty and Manufacturing Company. This electric device, designed by Missel, was powered by D batteries laid front to back in a paper tube with the light bulb and a rough brass reflector at the end. The company donated some of these devices to the New York City Police, who responded favorably to them. Carbon filament bulbs and fairly crude dry cells made early flashlights an expensive novelty with low sales and low manufacturer interest. Development of the tungsten filament lamp in 1904, with 3 times the efficacy of carbon filament types, and improved batteries, made flashlights more useful and popular. The advantage of instant control, and the absence of flame, meant that handheld electric lights began to replace combustion-based lamps such as the Hurricane lantern. By 1922 several types were available: the tubular handheld variety, a lantern style that could be set down for extended use, pocket-size lamps for close work, and large reflector searchlight-type lamps for lighting distant objects. In 1922 there were an estimated 10 million flashlight users in the United States, with annual sales of renewable batteries and flashlights at $20 million, comparable to sales of many line-operated electrical appliances. Flashlights became very popular in China. By the end of the 1930s, 60 companies made flashlights, some selling for as little as 1/3 the cost of equivalent imported models. Miniature lamps developed for flashlight and automotive uses became an important sector of the incandescent lamp manufacturing business. Incandescent flashlights use incandescent light bulbs, which consists of a glass bulb and a tungsten filament. The bulbs are under vacuum, are filled with argon. Krypton is xenon. Some high-power incandescent flashlights use a halogen lamp where the bulb contains a halogen gas such as iodine or bromine to improve the life and efficacy of the bulb. In all but disposable or novelty flashlights, the bulb is user-replaceable. The bulb life may be only a few hours. The light output of an incandescent lamp in a flashlight varies widely depending on the type of lamp. A miniature keychain lamp produces 1 or 2 lumens. A 2D cell flashlight using a common pre-focus style miniature lamp will produce on the order of 15 to 20 lumens of light and a beam of about 200 candle power. One popular make of rechargeable focusing flashlight uses a halogen lamp and produces 218 lumens. By comparison, a 60-watt household incandescent lamp will produce about 900 lumens. The luminous efficacy of lumens produced per watt of input of flashlight bulbs varies over the approximate range of 8 to 22 lumens watt, depending on the size of the bulb and the fill gas, with halogen-filled 12-volt lamps having the highest efficacy. LED, powerful white light-emitting diodes are increasingly replacing incandescent bulbs in practical flashlights. LEDs existed for decades, mainly as low-power indicator lights. In 1999, LumiLEDs Corporation of San Jose, California, introduced the Lacon LED, a high-power white light emitter. This made possible LED flashlights with power and running time better than incandescent lights. The first Lacon LED flashlight was the ARC-LS, designed in 2001. White LEDs in 5mm diameter packages produce only a few lumens each. Many units may be grouped together to provide additional light. Power LEDs drawing more than 100 mA each simplify the optical design problem of producing a powerful and tightly controlled beam. LEDs can be significantly more efficient than incandescent lamps, with white LEDs producing on the order of 100 lumens for every watt, compared to 8 to 10 lumens per watt of small incandescent bulbs. And LED flashlight will have a longer battery life than an incandescent flashlight with comparable output. LEDs are also less fragile than glass lamps. LED lamps have different spectra of light compared to incandescent sources, and are made in several ranges of color temperature and color rendering index. Since the LED has a long life compared to the usual life of a flashlight, very often it is permanently installed. LEDs generally must have some kind of control to limit current through the diode. Flashlights using 1 or 2 disposable 1.5-volt cells require a boost converter to provide the higher voltage required by a white LED, which need around 3.4 volts to function. Flashlights using 3 or more dry cells may only use a resistor to limit current. Some flashlights electronically regulate the current through the LEDs to stabilize light output as the batteries discharge. LEDs maintain nearly constant color temperature regardless of input voltage or current, while the color temperature of an incandescent bulb rapidly declines as the battery discharges, becoming redder and less visible. Regulated LED flashlights may also have user-selectable levels of output appropriate to a task, for example, low light for reading a map and high output for checking a road sign. This would be difficult to do with a single incandescent bulb since efficacy of the lamp drops rapidly at low output. LED flashlights may consume 1 watt or much more from the battery, producing heat as well as light. In contrast to tungsten filaments, which must be hot to produce light, both the light output and the life of an LED decrease with temperature. Heat dissipation specification for the LED often dictates that small high-power LED flashlights have aluminium or other high-heat conductivity bodies, reflectors and other parts to dissipate heat. They can become warm during use. Light output from LED flashlights varies even more widely than for incandescent lights. Keychain-type lamps operating on button batteries or lights using a single 5mm LED may only produce a couple of lumens. Even a small LED flashlight operating on an AA cell but equipped with a power LED can emit 100 lumens. The most powerful LED flashlights produce more than 1000 lumens and may use multiple power LEDs. LEDs are highly efficient at producing colored light compared with incandescent lamps and filters, and LED flashlight may contain different LEDs for white and colored light, selectable by the user for different purposes. Colored LED flashlights are used for signaling, special inspection tasks, forensic examination, or to track the blood trail of wounded game animals. A flashlight may have a red LED intended to preserve dark adaptation of vision. Ultraviolet LEDs may be used for inspection lights, for example, detecting fluorescent dyes added to air conditioning systems to detect leakage, examining paper currency, or checking UV fluorescing marks on laundry or event ticket holders. Infrared LEDs can be used for illuminators for night vision systems. LED flashlights may be specified to be compatible with night vision devices. HID, a less common type of flashlight, uses a high-intensity discharge lamp as the light source. Unhid gas discharge lamp uses a mixture of metal halide salts and argon as a filler. HID lamps produce more light than an incandescent flashlight using the same amount of electricity. The lamp will last longer and is more shock-resistant than a regular incandescent bulb, since it lacks the relatively fragile electrical filament found in incandescent bulbs. However, they are much more expensive due to the ballast circuit required to start and operate the lamp. Unhid lamp requires a short warm-up time before it reaches full output. A typical HID flashlight would have a 35-watt lamp and produce more than 3000 lumens. Accessories. Certain accessories for a flashlight allow the color of the light to be altered or allow light to be dispersed differently. Translucent colored plastic cones slipped over the lens of a flashlight increase the visibility when looking at the side of the light. Such marshalling wands are frequently used for directing automobiles or aircraft at night. Colored lenses placed over the end of the flashlight are used for signaling, for example, in railway yards. Colored light is occasionally useful for hunters tracking wounded game after dusk, or for forensic examination of an area. A red filter helps preserve night vision after the flashlight is turned off, and can be useful to observe animals without disturbing them. Detachable light guides, consisting of rigid bent plastic rods or semi-rigid or flexible tubes containing optical fibers, are available for some flashlights for inspection inside tanks, or within walls or structures. When not required, the light guide can be removed and the light used for other purposes. Formats and specialized designs. A penlight is a small, pen-sized flashlight, often containing 2 AA batteries or AAA batteries. In some types, the incandescent light bulb has an integral lens that focuses the light, so no reflector is built into the penlight. Others use incandescent bulbs mounted in reflectors. LED penlights are becoming increasingly common. Low-cost units may be disposable with no provision to replace batteries or bulbs, and are sometimes imprinted with advertising for promotional purposes. A headlamp is designed to be worn on the head, often having separate lamp and battery components. The battery pack may be attached at the back of the head or in a pocket to improve balance. Headlamps leave the user's hands free. A headlamp can be clipped to the brim of a hat, or built to mount on a hard hat, instead of using straps. Other types resemble eyeglass frames. Similar to the headlamp, an angle head flashlight emits light perpendicular to the length of the battery tube. It can be clipped to a headband, belt, or webbing set on a flat surface. Some types allow the user to adjust the angle of the head. The Fulton MX991U flashlight was an angle head flashlight issued to U.S. military personnel. Similar style lights remain popular. Tactical lights are sometimes mounted to a handgun or rifle. They allow momentary illumination of a target. They are small enough to be easily rail-mounted to a gun barrel. Tactical lights must withstand the impact of recoil, and must be easily controlled while holding the weapon. Although most flashlights are designed for user replacement of the batteries and the bulb as needed, fully sealed disposable flashlights, such as inexpensive keyring lights, are made. When the batteries are depleted or the bulb fails, the entire product is discarded. Diving lamps must be watertight under pressure and are used for night diving and supplemental illumination where surface light cannot reach. The battery compartment of a dive lamp may have a catalyst to recombine any hydrogen gas emitted from the battery. Since gas cannot be vented in use, people working in hazardous areas with significant concentrations of flammable gases or dusts, such as mines, engine rooms of ships, chemical plants or grain elevators, use non-incendiary, intrinsically safe, or explosion-proof flashlights constructed so that any spark in the flashlight is not likely to set off an explosion outside the light. The flashlight may require approval by an authority for the particular service and particular gases or dusts expected. The external temperature rise of the flashlight must not exceed the auto-ignition point of the gas, so substitution of more powerful lamps or batteries may void the approval. Inspection flashlights have permanently mounted light guides containing optical fibers or plastic rods. Another style has a lamp mounted at the end of a flexible cable, or a semi-rigid or articulated probe. Such lamps are used for inspection inside tanks, or inside structures such as aircraft, where used for inspecting the interior of tanks containing flammable liquids. The inspection lights may also be rated as flame-proof so that they cannot ignite liquids or vapors. Otoscopes and ophthalmoscopes are medical instruments that combine a handheld light source and magnifying lenses for examination of the ear canal and eyes, respectively. Many flashlights are cylindrical in design, with the lamp assembly attached to one end. However, early designs came in a variety of other shapes. Some resembled candlesticks with a bulb mounted at the top of a battery tube fixed to a flat base with a handle. Many resembled lanterns, consisting of a battery box with a handle and a lamp and reflector attached to the front. Electric lanterns are used for lighting the broad area immediately around the lantern. As opposed to forming a narrow beam, they can be set down on a level surface, or attached to supports. Some electric lanterns use miniature fluorescent lamps for higher efficacy than incandescent bulbs. Portable handheld electric spotlights can provide larger reflectors and lamps, and more powerful batteries than tubular flashlights meant to fit in a pocket. Multifunction portable devices may include a flashlight as one of the features. For example, a portable radio flashlight combination. Many smartphones have a button or software application available to turn up the screen backlights to full intensity, or to switch on the camera flash or video light, providing a flashlight function. as well as utilitarian flashlights. Novelty, toy and ornamental portable electric lights have been made in a myriad of shapes. In the 1890s, one of the earliest portable battery light applications was a type of novelty porcelain tie-pin with a concealed bulb and battery, reflectors and lenses. A reflector with an approximately parabolic shape concentrates the light emitted by the bulb into a directed beam. Some flashlights allow the user to adjust the relative position of the lamp and reflector, giving a variable focus effect from a wide floodlight to a narrow beam. Reflectors may be made of polished metal or glass or plastic with an aluminized reflective finish. Some manufacturers use a pebbled or orange peel instead of a smooth reflector to improve the uniformity of the light beam emitted. Where multiple LEDs are used, each one may be put in its own parabolic reflector. Flashlights using a total internal reflection assembly have a transparent optical element to guide light from the source into a beam. No reflector surface is required for a given size of light source. A larger reflector lens allows the tighter beam to be produced, while capturing the same fraction of the emitted light. The reflector may have a flat transparent cover to keep out dirt and moisture, but some designs have a plastic or glass bullseye lens to form a concentrated beam. The lens or reflector cover must resist impacts and the heat of the lamp, and must not lose too much of the transmitted light to reflection or absorption. Very small flashlights may not have a reflector or lens separate from the lamp. Some types of penlight bulbs or small LEDs have a built-in lens. A reflector forms a narrow beam called the throw, while light emitted forward misses the reflector and forms a wide flood or spill of light. Because LEDs emit most light in a hemisphere, lens lights with a LED facing forward or reflector lights with it facing backwards radiate less spill. Variable focus, zoom or flood throw lights may move the reflector or lens, or they may move the emitter. Moving the emitter presents the designer with the problem of maintaining heat dissipation for the LED control switch. The original 1890s flashlights used a metal ring around the fiber body of the flashlight as one contact of a switch, and the second contact was a movable metal loop that could be flipped down to touch the ring, completing the circuit. A wide variety of mechanical switch designs using slide switches, rocker switches, or side-mounted or end-mounted push buttons have been used in flashlights. A common combination is a slide switch that allows the light to be left on for an extended time, combined with a momentary button for intermittent use signaling. Since voltages and currents are low, switch design is limited only by the available space and desired cost of production. Switches may be covered with a flexible rubber boot to exclude dirt and moisture. Another common type of switch relies on twisting the head of the light. Weapon-mounted lights may have remote switches for convenience in operation. Electronic controls allow the user to select variable output levels at different operating modes such as pre-programmed flashing, beacon or strobe modes. Electronic controls may be operated by buttons, sliders, magnets, rotating heads, or rotating control rings. Some models of flashlight include an acceleration sensor to allow them to respond to shaking, or to select modes based on direction the light is held at switch on. At least one manufacturer allows user programming of the features of the flashlight through a USB port. An electronic control may also provide an indication of remaining battery capacity, or automatic step-down of brightness as the battery nears full discharge. Materials. Early flashlights used vulcanized fiber or hard rubber tubes with metal end caps. Many other materials including drawn steel, plaited brass, copper, silver, even wood and leather have been used. Modern flashlights are generally made of plastic or aluminum. Plastics range from low-cost polystyrene and polyethylene to more complex mixtures of ABS glass-reinforced epoxies. Some manufacturers have proprietary plastic formulations for the products. A desirable plastic for manufacturing flashlights allows for ease of molding and adequate mechanical properties of the finished flashlight case. Aluminum, either plain, painted or anodized, is a popular choice. It is electrically conductive, can be easily machined, and dissipates heat well. Several standard alloys of aluminum are used. Other metals include copper, stainless steel, and titanium, which can be polished to provide a decorative finish. Zinc can be die-cast into intricate shapes. Magnesium and its alloys provide strength and heat dissipation similar to aluminum with less weight, but they corrode easily. Metals may be drawn into a tubular shape, or tubular extruded stock can be machined to add threads for the head and tail cap, knurling for grip, and decorative and functional flats are holes in the body. LED flashlights may have cooling fins machined into the metal cases. Plastics are often injection molded into nearly final shape, requiring only a few more process steps to complete assembly. Metal cases provide better heat dissipation for the lead, but plastics are not electrically conductive and may resist corrosion and wear.